Hi everyone. So we're on page 390 in the binder. We're going to talk a little bit about solving equations when they're in factored form. So to start, we've got this warm-up at the top. You can see these 4 problems, easy ones. I want you to pause the video and solve them on your own here. 1 through 4. All right, now you can check your answers. Hopefully you agree with me on those. Easy stuff here. All these equations were equal to 0. We isolated the x and divided if we need to then. So these are known as solutions. You've heard that word before. They can also be called zeros because they're the x value that makes the equation equal to 0. And sometimes they're called roots of polynomial equations. And so one other thing to remember is when we're solving, we can always check our answers by plugging back in the solution to the equation to see if it's true. Okay, so then what we've got here in example 1 just says fill in the blank with any possible values that make it a true statement. So the first one is something times 10 equals 20. Well, that's got to be 2. Something times 4 equals 24. What would that be? That would be 6. 8 times something equals 40. That would be 8 times 5. Now in the next line here, it's both are blank. Something times something that equals 12. So there's a lot of options. 1 and 12, 2 and 6, 3 and 4. You can pick whatever you want. I'll do 1 and 12 for this one. For 36, we could do lots of different things. Maybe for this one, we'll do 4 and 9. 23. I think that only has one option. 23 is prime, so that's 1 and 23. But now on these next ones, it's blank times blank equals 0. Well, how do we know if a multiplication problem equals 0? Well, one of the things has to be 0, right? So I could have like 5 times 0, and I just picked 5 randomly. I could have 0 times 8. I could even have 0 times 0, right? All right, we're going to skip example 2 because I think that chart often is more confusing than helpful. But what I want you to notice is in this example 1, the only way an equation, a multiplication problem, will ever equal 0 is if one of the things that is one of the factors is 0. Right? So that leads us to a really important property, and you're going to hear us say this over and over again, the zero product property. Right? And it says that if a and b are real numbers and a times b equals 0, then a has to equal 0 or b has to equal 0. Right? We know that if a multiplication problem equals 0, one of those two factors being multiplied must equal 0. A different way to think of it is if triangle times square equals 0, then triangle or the square, one of them has to equal 0. So we use this to our advantage when we have something that's in factored form. So let's flip to the next page, 391, and take a look. All right, here we are on 391, and at the top there, it says solve each factored polynomial equation. Remember, you can always check your answers. Okay, so what we have here is essentially a problem that says a times b equals 0. So the zero product property said that if a, b equals 0, then a equals 0 or b equals 0. So what we do is we take each factor and I write it as a new equation equal to 0. So either x plus 3 has to equal 0 or x minus 8 has to equal 0. And those are nice and easy to solve. Subtract 3, x equals negative 3, or add 8, x equals 8. And those are my two answers. Now let's check, just to show you. So what if I make x equal to negative 3? Well, then I have, and I plug it back into the original, negative 3 plus 3 times negative 3 minus 8. And what is that? Does that equal 0? Well, that's 0. Negative 3 plus 3 is 0 times negative 11, which does equal 0. So it works. What if I check x minus 8? Or x equals 8. So if I check x equals 8, I would have 8 plus 3 times 8 minus 8. 8 plus 3 is 11, but 8 minus 8 is 0. 11 times 0 is 0. So we're happy again. Both of them work. That's the point of this zero product property, is we set each factor equal to 0, and then we can get our solutions by solving those little mini equations. So I want you to try B now. It's equal to 0, and that's really important. It's factored. It's a times b equals 0. So I'm going to write x plus 16 equals 0, and I'm going to write x minus 1 equals 0. Minus 16, x equals negative 16, plus 1, x equals 1. Technically, you should put word or in between because it's one or the other. X can't be both things at the same time. But those are my two answers. What about C? Again, I'm a times b equals 0. So I've got these two factors. I'm going to separate them. I'm going to write 2x minus 5 equals 0. And I'm going to write 4x plus 1 equals 0. These ones are a little harder to solve, so we'll go one step at a time here. Add 5, so it's 2x equals 5. Divide by 2, x equals 5 over 2. And remember, if ever I'm going too fast, pause the video, get caught up on the writing, and then restart. Minus 1, 4x equals negative 1. Divide by 4, x equals negative 1/4. Both of these are fractions, that's okay. Those are the two solutions. Problem D. 3 times x plus 2 equals 0. All right, so I've got two factors, so I'm going to take each one and set it equal to 0. 3 equals 0, and x plus 2 equals 0. Well, wait, 3 equals 0, that's nothing. Like, that part has no solution, right? There's no x there. But x plus 2 is minus 2, so I get x equals negative 2. So that one just has one answer. But problem E is a little different. It says x times x minus 1 equals 0. So same thing, I still have two factors. I write each one equal to 0. So x equals 0, x minus 1 equals 0. Well, x equals 0, that's done. There's an answer. X minus 1, I would add 1 to both sides, I get x equals 1. Okay, that one has two answers there. So F is kind of similar to E. I have two factors again, right? Each one equals 0. 2x equals 0, 6x minus 5 equals 0. Well, 2x equals 0, that's saying 2 times something equals 0. Well, if it's 2 times something and the answer is 0, that something has to be 0. I could also divide by 2 and get x equals 0, or, and then here I would have add 5, so I'd get 6x equals 5. Divide by 6, I would get x equals 5, careful, over 6. There's my two answers there. Okay. Sometimes we might have 3 factors. That's okay. That's the great part about the zero product property. We just write each one equal to 0. So 2x minus 1 equals 0, x minus 1 equals 0, x plus 3 equals 0. So I got add 1, 2x equals 1, divide by 2, careful, it's 1 over 2, so that's 1/2. Add 1, x equals 1, subtract 3, x equals negative 3. So this problem has 3 answers. All right, we're almost done here. Let's just finish these two up, why not? So that's a negative in front. Is there an x there? No, it's really just like negative 1 times a times b. Well, since negative 1 doesn't have an x, I mean, I could write negative 1 equals 0, but I know that part's going to be no solution. So what I really care about is the two factors that involve x. X minus 1 equals 0, so that's going to be x equals 1. And then x minus 4 equals 0, so that's going to be x equals 4. Because I add 1, I add 4. Same thing with j. I've got that 2 there. Okay, and that 2, I would just write 2 equals 0, but no, it's no solution. I know that. It doesn't involve an x. F, problem F, look at the difference. Problem F, it was 2x. There's an x there, so I'm getting an answer, x equals 0. But here's just 2. Do you see the difference? It's really important. Okay, so then for this, I just have x plus 6 equals 0. And the other one's the same. I don't need to write it twice. It's just x plus 6 equals 0. I'm going to get the same answer. Subtract 6. X equals negative 6. There we go. All set. Hopefully this is making sense. If not, make sure you're asking questions in class. Thanks for watching.